My name is Michael Schloter. I'm from Munich. I'm working at the Helmholtz Center in Munich, and I have a second affiliation at the Technical University. I'm heading an institute called Comparative Microbiome Analysis. So we are mostly interested in host microbe interactions, and one of the interactions that we are currently working most is plant microbe interactions, because we want to understand how microbes can improve plant growth. And there, of course, the microbiome in the soil and the microbiome at the plant-soil interface is of high importance. We have been working a lot on topsoils, and we have found a lot of different traits that microbes have where they can support plant growth, like biocontrol, like production of phytohormones, like mobilization of nitrogen and phosphorus. However, we do not know exactly what happens in the subsoil. We know that there are different microbial communities. We know that they have different functional traits, but at the moment we do not know how they are activated. We do not know how they interact with the plant, and we do not know at all how these plant microbe interactions really work. This is why I'm here, because I want to know more about these interactions. I want to know more about mainly the genetics of the plant, which I think drives to a large extent root development. And I think this is very important if we want to understand interactions, because interaction means for me not having the one part as a black box and having for the other part things in very much detail. Interaction means that we understand the plant, and there is where we need collaboration, and to understand then better what the microbes do and how they can support plant growth. I'm really amazed how progress has been made in that field. We have been working on subsoils, I think 5 or 6 years ago, and there the technologies how to investigate subsoils were at the very beginning. Now there are techniques like computer tomography available, where we really can link now also on a spatial scale microbial pattern to pattern of the plant and of the plant roots. And I think this is very important when we want to understand interactions. On the other hand, I've learned a lot about genetics, that genetics also in the field of plant sciences improved a lot, and now it's really possible to link phenotypes of the plants to the phenotypes of the microbes. However, of course, this again means that we need methodological developments, because everything that we are doing in the field of microbiome research means destructive sampling. And of course, when you consider all the efforts that have been made to set up the experiments, it is very obvious that it is not possible to sample in a high throughput manner, which would be needed. So we have to think about technologies where we can understand the microbiome but not destroy the whole experiment.